Hi guys, I welcome you all to my channel CSNet Lectures. So in this session, we are going to start up with a new topic, that is Q data structure. So in the last classes and all, we discussed about stack, infix, prefix conversions and arity and so on and so on. So now this type is also a very important one. So in this session, we are going to discuss about what is a queue, why it is used and with the way of representing it. So all these things we are going to cover it over here. Okay, so in the next session, we are going to see its simple algorithm implementation, friends. Right? So without any delay, shall we proceed for the topic? Right. So now, what is a queue? So queue, it is a linear data structure. So what is a linear data structure? So the linear data structure is going to store the elements in a contiguous manner. That is what is called contiguous. The elements are going to get arranged one by one in sequential manner with having sequential memory addresses. So that is called as a linear data structure, right? So Q is also one such type. Okay, so now the insertion and deletion of Q data structure is based on FIFO. What is FIFO? FIFO stands for first in first out method. Okay, it stands for first in first out method. Okay, so now first you should have to know what is a queue in a general concept. So if you see in any type of cinema theaters or any type of shopping malls or wherever we go, what we will do, the people, suppose if they want to pay the bill, they must have to stand in line, isn't it? So they will be standing in queue for getting the tickets or paying the grocery bills or whatever it is. So the first person who is standing near the counter, he will be finishing off all the processes and he will move, and the next person is going to come, isn't it? So if you see, the person who is arriving first, he will be leaving from the counter. So the same thing is going to happen over here. And the person who is arriving at the last, where he will be standing. So he will be standing to the place next to the last person. Okay, so the person who is going to buy the ticket will leave first, and the person who is arriving at the last will stand at the last. So in the same way, the insertion here is going to happen in one direction, and the deletion is going to happen in another direction. So we are going to use two pointers, right? So one pointer is used for insertion and another pointer is used for deletion. But in stack, if you see, we were using only one pointer because the insertion and deletion was going to take place at the topmost position, isn't it? But here we are using two pointers. Okay, so the name of the pointer is front and rear. So the name of the pointer is front and rear. So front pointer is a pointer used for making a track of the person who is arriving at the first, right? And rear is a pointer which is going to monitor on the person or element who is coming at the last. Okay, so for that we are using two pointers, right? So now the another name for rear is NQ. NQ is adding the element at the last, right? So these are certain names which you should have to keep it in mind, friends, right? So what is front? Front is deletion. Okay, as I told, a person who is going to get the ticket first will be moving out of the counter. So it is something but deletion. So DQ or delete, NQ or add. Okay, so these are the two pointers which we are going to use it. Okay, friends. So now, how we are going to delete and how we are going to insert the element from the queue? So I told we are going to use two pointers, isn't it? Suppose in the stack, if you see, we were using a topmost pointer. So what the topmost pointer will do? Suppose if I want to push an element. Okay, if you want to push an element, I will be incrementing the pointer to one position and then I will insert. Isn't it? Suppose if I want to delete an element, I will be deleting, that is I will be popping out the element and I will decrement the pointer to a location 1 in a downward direction. Isn't it? So same way here we are going to use 2 pointers. Right. Suppose if I want to insert an element, I want to increment the rear pointer. Okay, so the pointer name is front pointer and rear pointer. Rear pointer is used for insertion and front pointer is used for deletion. Suppose if I want to insert an element in an empty queue, I want to increment the rear pointer and then I should insert. Okay, C plus 1. Now, if I want to delete an element from the queue, what I should do? I must have to remove that element and I must have to increment the pointer to the next successive first element. Okay, so we are using 2 pointers for insertion and for deletion, right? So now I am going to explain it to you with a simple example. Okay, so for example, let me take an array data structure. So in this array structure, I am going to insert and delete elements by using queue concept. Okay, so shall we start? Right. So initially if you see, the size of the array data structure is 1, 2, 3, 4, 5, 6 and 7. So size of the data structure is array is 7. So now in this array, I am going to store the elements, that is I am going to start to store the elements. So as I told, I must have to use 2 pointers initially. Okay. So now, is there any elements present? No, there is no element. So now I am going to start insert the element. So how to use the pointer now? How to use it? So now if you see, as there are no elements, as the queue is empty, I am going to place the pointers outside the queue structure. See, let it be here, front and rear, because I am using 2 pointers, isn't it? So now let this value be -1. Okay, now let this rear value be -1. Okay, keep that in mind. F is for front and R is for rear. As there are no elements, initially F value is -1 and R value is -1. Okay, so this is the first value if the queue is empty. This you must have to keep it in mind. Okay, so now an element is going to come. Okay, for example, let the element be 10. Right, let the element be 10. How I will be inserting? Since the queue is completely empty, I can directly insert it, isn't it? So now, friends, another thing is that now I am going to explain you the concept of queue insertion deletion. In the next video, while explaining about the algorithms, I will tell you what to do if the queue is full or the queue is empty, where will be the rear pointer, all those things we will discuss it in the next classes, right? So now, as this is the first element, now I want to insert this element. How I will insert? I must have to place the front pointer in this location, isn't it? First what I should do, I must have to increment the front pointer and then I must have to insert, right? So now place the front pointer here. Now what is the front pointer value? So it will be 0. So now can I insert 10? Yes. So now I can insert 10. Now the front or the first element is 10. So now what I will be doing with this rear pointer? See, I must have to move this rear pointer also here because as there are no elements subsequently, this is the only one element arrived. So front element is also 10 and the last element is also 10. Okay, so the first element is also 10 and the last element is also 10. So I must have to mention the memory that the queue is having front element as 10 and rear element is also 10. So now front value is 0 and R value is 0 now. Okay friends, so now next instantly another element is going to come, let it be 20. another element is going to come, let it be 20. So now in this queue, how I am going to insert it? What I should do? I must have to increment the rear pointer. Okay, so front, as I told, it is always going to point only to the first element, because the first person must have to leave the counter, isn't it? So at present, the first element is always 10 only. Okay, so now as 20 element is arriving, now in this case 20 is going to be the second last element and 10 is the first element, isn't it? So now if you see, I must have to increment the rear pointer, because the rear must have to point to the last element, isn't it? So now increment the rear pointer. Okay, so now if you increment, now rear value has to be 1. Real value is now 1. Since this is the last element 20, you can insert it. Okay, so now if you visualize this structure, you will be able to clearly understand that front element is now 10, last element is 30. Okay, because front is always pointing to the first element, rear is going to add the subsequent last elements that is going to come. Okay friends, clearly understand. Now we are going to go on increment the rear pointer, because insertion is taking place, isn't it? So now let 30 comes. 30 is the next element. So now 30 is going to be the last element. I want to add it here, isn't it? So which pointer I must have to increment? So rear pointer I must have to increment. So increment the rear pointer R. Now R value is 2. Now add this 30. Okay. So now if you see, front is always pointing to 10. R is now 30. Okay. So now let the other element be 35. Now I want to insert the element 35. So what I should do? I must have to increment the rear pointer, as it has to point to the coming last element 35. So now increment, so R will be here, now it is 3, so insert as 35. Now R is 2 and it is 3. Friends, are you all clear? Right. So now as I go on add the elements, so if you see now, the next subsequent elements are 38, 50 and 55. Now I am going to add it. So 38, after incrementing R, I am inserting 38. Again this is the next element. So after incrementing R, my next element will be 50. After incrementing R, I will be inserting 55. Now R is pointing to the last element, which is 55. Now R value is finally 6. Okay. So now we have inserted all the elements of the queue. Now can you tell me which person has arrived at the last? So 55 is the person who arrived at the last. So now this is the person who came at the first. So he is having the priority of leaving from the counter. So as now front is pointing here. Okay friends. So now shall we perform the deletion operation? Okay. So now we are going to delete the elements from the queue. So since we are moving for deletion operation, what pointer I must have to use? So I must have to use the front pointer. Okay, because as we are going on leaving the person who has got the ticket, I must have to make the next person as the first one to leave, isn't it? So for this, front pointer is going to play the maximum role, right? So now I am going to delete the elements. So now as you see, initially what is the value of F now? So the initially F value is 0, isn't it? Now I want to delete this 10. Shall I delete it? Okay. So if I delete this element, now at this time, which is the first element now? So the first element has to be 20, isn't it? So this front pointer has to point to 20th element as a first. So what you should do is, you must have to increment the front pointer here. So 0 is incremented to 1. So now f value is 1. Okay friends, are you all clear? So like this only you should have to delete it. So now if I am going to delete this 20, now which is the first element? So the first element is 30, isn't it? So now front has to point to this 2. Okay, so now the front value is 2. Okay, so now if I am going to delete this 30 also, now what will be the front value? So the first value is 35. So f is going to point it here. Okay, so what is f value? F value is 3. So like this I will be deleting all the elements until the last element is reached. So now you see, so 35 is deleted. Okay, so now f value is 4. F will be pointing here, isn't it? So now 38 is also deleted. So f has to point to this location. So f is 5. So now if you see, 50 is also getting deleted. Okay, 50 is also getting deleted. So now which will be the first element? So the first element is also now 55. So now at this situation, front pointer and rear pointer both are pointing to the first and last element, which is present only one. It is 55. Okay friends, are you all clear? So like this only we must have to do the insertion and deletion. So now at the last, f is also 6 and rear is also 6. Okay, so once you delete this also, suppose we delete this 55, now what will be the value of front and rear? So once again it will be re-incremented to f. Okay, f and r 0. Okay friends, so in this way only we must have to do the insertion and deletion of elements in the Q data structure. Friends, are you all clear now? So friends, now I am going to tell you some of the conditions which is related to that of front and rear pointer, where the position has to be. All these things I am going to explain it to you because these are very important in case of examination point of view. Okay friends, these are the different conditions that they may ask in the examination point of view for whether the queue is full, what is the condition, for queue is empty, what is the condition, for if one element is present in the queue, what is the condition. So like this they may ask. Okay, so now we are going to have a short discussion. Please you must have to remember this friends because these may be the direct questions. First condition is, there are two conditions if the queue is going to be full. So if queue is full, what is the location of the front and rear pointer? So this just now we have discussed, isn't it? So the first will always point to the first element and r will always point to the last of the element. So that is r is equal to n. So n stands for maximum size. Okay. So this is the first condition. So f equal to 0 and r is equal to n. Next, reset the value of f and r is equal to -1 if all the elements are deleted. So now once the queue has been full, we may have the possibility for deleting certain elements. Okay. So once if we go on delete the elements, as I drew a diagram in the last class, the same thing here. Okay, so if you see, I have deleted all the elements. The only one element is left over, that is 55. So this I am going to delete it. Right. So once I am going to delete this element, where I will be placing the front and rear pointers as I discussed in the last diagram. The same thing is here. Okay, where I will be placing the pointer. Is there any use of using the pointers? No. So after deleting this, I must have to relocate this front and rear pointer outside, that is f is equal to -1, r is equal to -1, because there are no elements in the queue. So I can leave the pointers from the data structure. So that is being written here. Okay, so if there are no elements, f and r value is going to be -1. Okay, so now these are the conditions if the queue is going to be empty. So the conditions are f is equal to r equal to -1. See here, there are no elements. Okay, so now what is the use of front and rear pointers? No, it doesn't going to play a role now until the element is deleted. So now at current, what is the position? So front is equal to -1 and r is equal to -1. So the same is being written here. So this you should have to remember. So next, r is equal to f minus 1. They may ask us, if q is empty, what is the value of r pointer? So if they ask like this, they will give some choices. In the one of the choices will be r is equal to f minus 1 if f equal to 0 and r equal to -1. If you substitute this, you will get the above answer. So what is f value? F value is 0. You substitute this, you will get as r is equal to -1. So they are twisting and asking you. Okay, so don't get confused, right? So now f is equal to null. So what is null? It is nothing but 0. Okay, so like this, these are the 3 conditions. You should have to keep it in mind if they ask you in examination. Okay friends, so now the condition if one element is present in the queue. So we have 2 conditions of question that they may ask you. So if front is equal to rear and it is not equal to null, is this true? So see, this is a queue data structure. I have stored only one element in the queue as is the maximum size. So I have inserted only one element. So now can you tell me, is the queue is empty or not? So queue is not empty because it is having the single element, isn't it? So how can you tell it is empty? It is not. So but what is the pointer's value? F is equal to 0 and r is equal to 0 because initially we are having front and rear as -1. So based on that, we are incrementing the front and rear pointer and we are placing the 55th element inside the queue. So this condition is true. We cannot tell as it is a null. So now front, what will be the front value if one element is present in the queue? Now can you tell me the answer for this? So as initially we have r as -1, isn't it? So r is -1. So if you substitute here r is equal to -1, what you will get? So the answer is -1 plus 1, you will get the answer as 0. Have you got f equal to 0? Okay, so like this, they will ask you some of the questions. Okay friends, so that's all. In this session we have discussed about the overall concept of representation of queue, insertion, deletion and so on. In the next video we are going to discuss about algorithm creation. Okay friends, bye and thank you.